Hello everyone. Hi. Today I will introduce you to something in number theory. Since you are JEE students, you might not have heard about number theory too much, but it's very interesting. And the idea that we will discuss today the to no the idea which will be required to solve the problem which is at hand today is very beautiful, and it's something I would like you two guys to see, to appreciate. It will tell you how mathematician thinks, how mathematics develops, and everything. And it's not just about computation here. I'm not going to tell you an algorithm through which you can solve problems. We're going to take a one particular problem, and we'll see how we can tackle it, not through any methods or anything. We're not going to discuss any methods today. The problem is this. I'll tell you what the problem is. Are there infinite number of primes? That's the question. Okay, so I'm just going to write it down here. We know what primes are. Primes are 2, 3. Hey, I'm just going to quickly zoom it out so it's much easier for you to guys to see. We've got 2, 3, 5, 7, 11, and so on. These are all the primes numbers that we have. What's the question here? This is what we will discuss in this video. One problem, and we'll see how we can handle it. And in the process, you'll see how beautiful the idea was that solves this. Question is this. These are all the primes. We know these are primes. Question is, does this list ever exhaust? क्या ये क्या ये list कभी खत्म होती है? Or are there infinite number of primes? That is to say, will this list keep on moving? बहुत सारे prime आते जाएंगे. It will never end. There will be infinite number of primes here. That's the question. This is what mathematicians were thinking a long time back. And this very question I ask this to you. What do you think? क्या primes कभी खत्म होंगे, or this list will keep on going? To answer this, how can we answer this? We have to answer this problem. Mm, I would like you to take some moment and think. One student might say that we can take the help of computers. We can ask the computer to find more and more primes. But such a method will only give you a new prime. Doesn't matter how many primes the computer gives you. 10 lakh, a trillion, a billion. Hmm? It will not guarantee that there are infinite number of primes. Something being infinite is very different from being trillion, trillion, or billion. Okay, so computer might not come to our rescue today, though they can help us find new primes. Well, somebody might say कि अगर computer हमेशा नया prime ढूंढता जाएगा, then it means we have infinite number of primes. But that's the catch here. We are not sure if the computer is able to find infinite number of primes. We use supercomputer, but supercomputers is it takes a long time for supercomputer to even come with new come up with a new prime. अभी ऐसा recently prime मिला था जो काफी लंबा है. I don't know the number of digits. I don't know how 100, possibly not 100, more than that digits. इतना बड़ा prime number. And अब नया prime ढूंढना है उसके बाद it requires a lot of computation power. So computers are working on it, but still to this day they have only been able to find a finite number of primes. That finite number could be very big, but it doesn't guarantee infinity. Okay, so here today in this video we will show that there are infinite number of primes, and in that process you will learn how mathematicians think, what is the importance of reasoning ideas, new ideas, how to generate new ideas. This is something you guys need to develop, this thinking, because this is what will be used in your JEE preparation when you face a new problem. um, When you go to some jobs, there will be new problems. You have to come up with new ideas. Mugging up the algorithm is not going to help you. The gist here is, can you think of some idea that will show there are infinite number of primes? Can you find the idea? Can you find the trigger? And mind you, it's not something you can't come up with yourself. The proof was given in 300 BC, which is a long time back, around these many years back. BC means before zero. There is a zero. There's no such thing as zero in years, but there was something 300s before the birth of Christ. Before BC means before Christ. So 300 years before Christ, this thing was proved by Euclid. Long before calculus, coordinate geometry was invented or discovered. Calculus, it was done in 17th century. Coordinate geometry is around 16th century by Descartes. So old proof doesn't require any fancy algorithm, mathematics, technique होगा, कोई सब्जेक्ट की कोई पर्टिकुलर कंसेप्ट, ऐसा कुछ नहीं. It just requires a very intelligent idea, an idea that you can come up with yourself if you ponder hard and long enough on it. So if you're interested, of course, have at it, give it a try, and see if you can come up with it. I'll tell you how do we do it, what's the idea, and how did Euclid went about in proving that this list never ends. It keeps on going forever. And this proof will introduce you to a very common way of doing problems in mathematics, which is proof by contradiction. How mathematicians thinks, how it's been done. So look carefully. What I'll do is I'll make an assumption. I assume, say there are finite number of primes. Assumption. I'll write the assumption, what the assumption is. Assumption. Say there are only finite number of primes. And say that list to be P1 starts from P1 and goes up till Pk. Say there are only k many primes here. We are assuming. So what I'll do is I'll assume there are finite number of primes, and then I'll arrive at a contradiction, which will show that the initial assumption of the finite number of primes that's not true. If we can arrive at a contradiction, I hope you got the hold of the idea. We assume there are finite number of primes, do some calculation, some work, arrive at a contradiction that tells you that your initial assumption was wrong. What you assumed, that there are finite number of primes, is not possible. There aren't finite number of primes. Okay. A very common, I'd say, proof by contradiction is very common in higher mathematics. You see, you might have done it already in your grade 10th. Yes. And when you tried proving if root 2 is irrational or rational, if root 2 rational or rational, the method which we used was method of contradiction. Same thing we're going to use it here. Okay, how? You're just going to love it. When I was first, shown this proof, I was amazed as to the question is so deep. If you were curious yourself, just imagine you're sitting in your room and you wanted to know it yourself. You weren't studying, watching this video, studying mathematics, whatever. You just know what prime numbers are. You just came upon this question all by yourself. How would you know if there are finite number of primes or infinite? It will boggle your mind for days. And the fact that there are ways through which we can assure that there are infinite number of primes is amazing. The idea, the logic, the mathematical logic, amazing. All right, let's see. How do we go about doing it? You have assumed there are only finite number of primes. What I'm going to do here is, say these are all the primes that there are. I'm going to create a number n. How do I create this number? By multiplying all these primes. I multiplied all these primes and added 1 to it. This is a number I created. Why did I create this particular number? You will see how. With the help of this number, I'll arrive at my desired goal. Okay, with the help of this number. Sir, how will I know this number is to be constructed? मुझे कैसे पता चलेगा यही करना है? See, you will come upon this question many times in your preparation. The answer to this question is practice. You see, solve enough problems, see a proof of few problems. After a while, after some time, you start, you know, you start okay, पता चलने लगेगा आपको कि where what to use, which thing to use, which will help me arrive at my result. This will all come with practice. It will indeed come. I too had this very question when I was preparing, and with after seeing enough mathematics, I don't know how it works. So just believe me. Do enough mathematics, you'll know. You'll start coming with such ideas yourself. Okay, we've got this number. Okay, suppose what could be the nature of this number? It could be a prime or it could be composite, right? There are only two options for it. Suppose it's composite. There are only two. We have a number n. There are two options. If either n is prime or n is composite, either it's prime or it's composite, right? Suppose n is prime. Suppose in this case n is prime. So what do you think? Does n belongs to this list? Obviously not, because n is a product of all these numbers, so it's much bigger than all the primes from this list. So n is a prime, not from this list. So I've got a new prime which is not in this list, say a prime n. But I assumed there are only finite number of primes and all the primes are these many. And now I'm saying I found a new prime outside this list. It's a contradiction, which is what we wanted. But we got a contradiction in this particular case if n is prime. What if n is composite? Suppose in this case also I can show you, or I can find a prime which is outside this list. In this case, I found a prime n itself which is outside this list. From this case also, if I can find a prime which is outside this list, say p0, then from both the cases I will have created a new prime outside this list, which will contradict our assumption that there are finite number of primes and all the primes that there were are all these primes. You assumed there are only k many primes. We did some work, some mathematical argument logic. With the help of it, we created a new prime outside that list. That tells you, I will tell you what it tells you. But for the moment, just suppose in this case we are able to find such prime. I will tell you how we can find it, but suppose we are able to find such prime. You might be wondering how. So let me just quickly show that to you first, and then we'll move forward, okay? All right. So what's the goal? We want to find a new prime outside this list. Okay. N is composite. That means a prime divides it. Okay. Prime. Some prime divides. Some prime divides n. Now the question is, can this prime be from this list? Can it be from this list? Suppose it can be. Suppose. Say it's PL. PL belongs to, let's call this set S. PL belongs to S and PL divides N. Then PL will divide P1, P2. Since PL is from that list, PL will come somewhere here, right? Because PL is from that S set, so it will come somewhere here. Now PL divides this whole thing, and PL being present here also divides this term because PL is present in this product. PL divides the whole thing, PL divides this term, and PL, this implies PL has to divide 1. This implies PL itself is 1. So if PL belongs to S and PL divides N, PL has to be 1, which is a issue because 1 is not a prime. That means PL cannot belong to the set S. We we assumed, say PL belongs to S. We arrived at a contradiction. This is symbol for contradiction. So PL cannot belongs to S. PL does not belongs to S. Some prime divides N and that prime cannot belongs to S. N was composite, therefore some prime had to divide N. That prime cannot belong to that list, and since it cannot belong to that list, it's outside that list, and let's call it PL. And this way we are able to find a new prime, which is again not from that list. Okay, let's quickly summarize what we just did. The question that we were dealing with is, does this list exhaust or not? Does this keep on going या फिर एक time पे आके we find all the primes and list is finished, exhausted? That was the question. Now we assumed, we made an assumption here. Suppose there are only finite number of primes कि ये list कभी ख़त्म हो जाती है and लिमिटेड नंबर ऑफ प्राइम्स हैं. अपन ने कहा कि से वो k नंबर ऑफ प्राइम्स हैं एंड फिर अपन ने एक नंबर कंस्ट्रक्ट किया n, उसकी मदद से अपन ने शो किया कि डजंट मैटर कि वो उसकी वजह से अपन ने कंस्ट्रक्ट किया एक नया प्राइम, डजंट मैटर n प्राइम है कंपोजिट, बोथ केसेस में एक नया प्राइम मैं कंस्ट्रक्ट कर सकता हूँ जो इस लिस्ट से बाहर है, एंड दैट टेल्स यू कि आपने जो एजम्पशन करी थी वो रॉन्ग है. मतलब आप कितने भी प्राइम ले लो, मैं हमेशा एक नया प्राइम ढूंढ पाऊंगा. आई कैन ऑलवेज फाइंड अ न्यू प्राइम, doesn't matter how many primes are there in that set. So this contradicts the assumption that there are finite number of primes. So this is how we show the infinite number of primes. And you might be wondering, why do I care about all this? I'll tell you why do you care about all this. All the securities that you see, internet security, your ATM pin, WhatsApp messages, online banking, encryption basically is all dependent on this. It's called, the subject is cryptography, which makes this algorithm and everything, and we rely on large primes to be able to make the system secure. The larger the prime is, the it's more difficult for the hackers to hack it because computation power is required and everything. So in security it's used, and that's the application. And Euler actually proved this theorem, and then mathematician further went on thinking ki there are more questions, whether there are infinite number of primes of this form or this form. Primes can only be of these 2 points, 4n plus 1, 4n plus 3. Any number of this form cannot be prime because 2 divides this number, right? And 4k of course 2 divides it. So the next question is, are there infinite number of primes of this type or this type? You can think about it yourself. Proof is again beautiful. This was for application and further things. And there are many things in number theory, though it's not a very central topic in JEE preparation, but I wanted to introduce this beautiful concept to all you guys since this uses such a beautiful idea to prove it. And yeah, it makes you appreciate mathematical reasoning much more. I hope you enjoyed it. Yeah.